Hey everybody, this is Larry. This is day 21 of the Leetcode Daily Challenge for September. Hit the like button, hit the subscribe button, join me on Discord, and let's get started on today's problem, carpooling. You are driving a vehicle that contains capacity MD. The vehicle only drives east, so going from left to right, say. Give me a list of trips from number of passengers starting and contains the number of passengers that must be picked up and the location picked up. Give me a Okay, return true if it's possible to drop them off. Okay. So, okay, and capacity is given to you. So yeah, this seems like a very... So basically because the car can only go from left to right, or you drive these, you basically have this thing where you just go from left to right, right? And from that, this motion or this idea, this visualization of going from left to right should give you an idea, which is the sweep line algorithm. And that's basically what I'm going to do by converting these into a series of events and then let people get off first and stuff like that. Basically very greedy, and then see whether we're able to. And we'll go over the details as I go do this, but that's the general idea. It's okay, for example, at station 1 you pick up two people, at station 3 you pick up 3, and that's not, it's not possible, right? And so stuff like that. Let me know what you think. I think this is okay, so let's see. So let's start with events. As you go to a list, and then 4, I'm just looking at the trips format. So yeah, 4 passengers, start and in trips. Let's put it in the events, right? So we add 2 events to each one. The first one is getting on, so we add the number of passengers on the start event, and then this latter one is the end, right? Or negative passengers, because that's how many passengers are getting off. The thing that I'm looking for here now is try to figure out whether we get off exactly at end location or end location minus or +1. Sometimes in the problem context you have to figure it out. In this case it is okay, and what I mean by that is that if 2 people get on at the same time, or if one gets off, or people get on and off at the same station, how do you resolve that, right? So in this case, I think it should be okay, because in this case, because the way that we sort, if there's a tiebreaker between 2 locations, the negative ones will always go first, and the invariant is that you will always have at most passengers on the ride, right? You can't go negative because you can't have negative passengers, right? So we want to greedy on, so that's why this sorting order is okay, because we want to greedy on the number of passengers first on the same point, but we're still going from left to right, so we're sorting on the starting points. So yeah, so I think that's all we need for this part, and then now we have to process each event at a time. So 4, let's call it station. Yeah, let's call it station. Just try and find naming. And passengers in events, right? So let's have also current passengers. Current number of passengers maybe is 0. And then here we go, okay. Current passengers, we could simulate, we add the number of passengers, and because we set the minus explicitly, this allow us to get negative passenger. So another way you can do this is actually have 2 events. So for example, for start you can have getting on event and a getting off event, right? And then in this case you would write maybe something like and then this is positive, and then you could something like if getting off you do negative or something like that, but that's already baked into how we structure this, so that's okay. And then now so there are 2 invariants that we want to keep here, right? The first one is passengers has to be greater than 0. And this one is trivially true because just by the way that we construct this, there's a symmetry to this, and assuming start is always going to be bigger than end, which seems to be the case here, you can, like, the number of negatives can only appear after the positive, so it's always going to be 0. But I'm just putting here for visualization, and we yeah, and so this is okay. And then the other one is within capacity, right? So that's the other thing that we're concerned with. So this is good, so we just continue. Maybe you could win in another way. Or maybe another way to write it is, if this is not true, then we return false, because that means that there's too many people on the train or on the bus or what, the car, or too few, right? So if at the very end we pass everything, then we can return true. And that's pretty much, I think that's pretty much it. We'll go over the complexity in a second. Let's put these things into the problem. Or the test cases in here. How did this appear? Did I? Oh. What is going on? Okay. Maybe I should have just done it a different way. I'm solving this live, so sorry, this is this part is less interesting. But anyway, okay, so run the code, run it, it should be good. Yeah, and then maybe the only thing I would check is like empty, or you know, maybe just too much too soon, or same station. I think, can it be same, they get on and off at the same station? No, it cannot, so okay. So let's say the next station, 1,000, I don't know, 10. Yeah, so just a few more test cases, and you could add as you. Ooh. Oh, I guess. That's weird. Where is the list index out of range? Did I have a typo? It's a little bit awkward, but I mean, I don't do anything. Why is that weird? Those trips would be just empty trips, right? So this doesn't. Actually, I don't know. Did I have a typo? Or an empty array? This index out of range. This is not this is not a standard Python error, so maybe it's just something on their side. I don't think. Let's prove me wrong. I'm gonna submit it. I'm confident enough about this. And yeah, it's accepted. They don't. They don't tell you that this could be greater than 0. That's why I added that test. But maybe there's something wrong on the server's problem or solution. But yeah. So what is the complexity of this? Well, we do create an event for every trip, or 2 events for every trip. So it's gonna be linear space, and with that result, it's gonna be 2n log 2n, which is n log n. So n log n time, n space, or O of n space. So yeah, that's the problem I have here, and it's pretty straightforward. And once you kind of get used to this technique, you can see that it's pretty straightforward, right? And it's very few places to make errors. So yeah, it's what I prefer. Anyway, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. How did you do? Do you like carpooling? Maybe not during the pandemic. But anyway, I will see y'all next problem tomorrow. Bye bye.